Aloha, everyone, and good morning. Welcome to another installment of the Women in Space Exploration Talk series, produced, supported by Pisces. My name is Mimi Fuchs. I'm a space enthusiast here on the Big Island, and I'm so excited to introduce our featured speaker for today, Monsi Roman. Born and raised on the island of Puerto Rico, Monsi was the chief microbiologist responsible for designing the life support systems on the International Space Station. Throughout her career, she's been active in mentoring STEM outreach events around the country. With her extensive knowledge and experience with this kind of technology to provide clean air and water for astronauts, like I mentioned, she was tasked with developing a new generation of life support systems that included sensors that could be used for human missions to Mars. She's the recipient of many NASA awards, including the prestigious NASA Spaceflight Awareness Honorary Award and the NASA Silver Snoopy Award. She received her master's in microbiology at the University of Alabama, Huntsville, and over the last few years, she's been serving as a program manager for NASA Centennial Challenges, where she encourages people to help solve some of the most technically challenging problems here on Earth and in outer space. Before I hand it over to Monsi, I would be remiss if I didn't mention that this talk series would not be possible without the support of our sponsors, Microsoft and the Hawaii Science and Technology Museum. So without further ado, I'm going to turn it over to Monsi. Remember, if this is your first time tuning in with us, the format of this speaker series is about 30 minutes of a presentation followed by a question and answer session. You don't have to wait till the presentation is over to send out your questions. So if something's exciting to you about Monsi's work, if a question pops into your head, go ahead, send it along to all of us on the meeting chat window. And because this talk is intended to help those participants who are early in their career, who maybe also want to work in the aerospace industry, if you are one of those participants, we want to make sure your questions are answered. So please, when you ask your question, include the hashtag WiSE so we know we can give your question priority. And without further ado, Monsi Roman, take it away.
Good morning, everybody. I'm so happy to be with you this morning. For you, it is actually afternoon here in Alabama is where I am, but from my background, you can see, I guess I'm on Mars. You can see out of my window over there, that's the surface of Mars. And so kind of exciting. So let's go ahead. Let me share my screen with you guys. I'm really, really excited to be here with you today. And I actually want to really invite you to ask me anything, truly. Feel free to ask any questions. I'll be happy to answer them. Let me put this in presentation mode so it's a little bit easier. Can you see them well now? Maybe? Okay. So again, my name is Monsi Roman. I work for NASA, have been working for NASA for quite some time. Let me get to my next slide. I was born in an island, just like the one you're living in. This one is in the Caribbean. It is not an, let me turn my video off because I'm having communication issues. I think this will help. So this is Puerto Rico in the Caribbean. It's not a very big island. So I know what it's like to grow up in a small island and live there for 22 years. So let's see what's going on. I actually have 3 boys, which you can see there, and that's my husband. We're a family of nerds, and if you can see where we're all on the surface of Mars, this was our Christmas card about 2 years ago. And not surprisingly, girlfriends and wives of the boys are also engineers. So I actually have one biologist, and my youngest one is a biologist, just like me. But the other 2 are engineers, and my husband is an engineer, and everybody else is an engineer. So it makes an amazing conversation at dinner for Thanksgiving and Christmas. And this is our baby. This is Luna, and Luna's an Australian Shepherd, and she's spoiled rotten. And started working for NASA in 1989, and it's one of the most awesome things I have ever done in my life. Some people have asked in the past, did I always wanted to work for NASA? And the answer is no, I never thought I would work for NASA. So I never even dreamed about working for NASA. So that was not something that was in my picture of the future. And when that the first opportunity opened to hire a microbiologist, and I applied and I got that position, truly I was over the moon. Kind of funny. Anyway, so, and this is a picture of me many years ago next to Atlantis, which was the last space shuttle that flew. And I had the opportunity to get that close to it. Of course, if I had touched it, I would have gotten in a lot of trouble because it was getting ready to be flown. So it was inside the shroud, and it was an amazing experience. I fell in love with microorganisms when I'd always loved biology. Went to the University of Puerto Rico, and there was able to take a microbiology class and fell in love with the subject. I ended up being a microbiologist, getting my degree in microbiology is the best thing I could have done. And by the way, I also love Disney World, so that's part of the reason here. But just think about all the Disney movies and all the, especially the older ones. The princesses were always the one that were cleaning and singing and wearing beautiful dresses. The witches of those movies were the ones in the laboratories with test tubes and cauldrons of stuff. And in particular, this is Madame Mim over there. And Madame Mim is a witch in the Sword and the Stone movie. And Madame Mim and Merlin have a duel. And Merlin actually wins the duel by becoming a microorganism and infecting Madame Mim. So anyway, just letting you know that they're all connected in there, even though it doesn't look like it is. So I studied, like I said, my bachelor's in the University of Puerto Rico, my master's at the University of Alabama in Huntsville, School of Sciences. And when I started in 1989 at NASA, we were flying missions from Earth to space that lasted at the most 2 weeks. 14 days were the longest missions that we had when we were only flying the shuttle. And of course, we had gone to the moon a few times, but just go there for a few days and come back. So those two things were already kind of done at that time. But I started at NASA when this notion of we want to go to stay in space for up to 6 months or a year started to come up as an idea. So when I started, literally the week that I started, I was assigned to work the group that was designing water and air systems for this thing that we were going to build in space that will keep people alive for 6 months to a year. So coming from 14-day missions to 6 months to a year, so now we were going to talk about recycling water and air, and nothing as important as water or air for the astronauts. I mean, food, they might be okay without it for a few days, perhaps, and other things. But I mean, just that. I mean, it became, I kept thinking, yeah, right, we're going to do this. But surely enough, we actually did it. And people don't think about it anymore. I mean, there's no news about it. But truly we are recycling, especially urine from the astronauts constantly in the space station. And that recycle comes back as drinking water. And as you can tell, it's probably the grossest thing you have ever thought of, right? Drinking, recycled urine. But I'm just going to share with you a little bit of information that you are drinking. The astronauts drink the water, recycled urine from people they know. We're drinking recycled water from people that we do not know, including cows and horses and dogs and anybody that goes and pees or whatever on the waters that comes back to you, to your house for drinking. So just a thought, and probably dinosaurs too, by the way. And so now we're looking at doing all these on our way back to the moon and on our way to Mars. So just gonna briefly cover a little bit of microbiology in the station to hopefully spark your curiosity about what we did and what we do and what needs to still be done. A lot of this is going to concentrate in the space station because it's our longest duration home that we have in space. But you have to think, as I am talking to you about what we did for station, that we are in the process of doing this again for Gateway, which will be our new home close to the moon, and then hopefully on the moon soon by after 2024, which is truly not that far from here. And so you're going to look that some of these pictures look extremely old. So the one to the left where it says where contamination can come from, of course, from pre-flight, because the hardware that goes up in space gets, actually touched by a lot of people before it gets to fly. It also comes from storage. What you see in the middle picture are bags of water stored for the crew to be used. And then what you see on the right picture, it's a panel. This is in the Russian segment of the space station, where for a while the astronauts were putting wet towels whenever they took, they wipe the skin or something to get refreshed. They don't have showers, so they don't take showers in station. They will leave the towels that were a little bit moist against the surface, and they started growing things. So that's, so just to think, everyday things that can get contaminated just by the fact that humans have microorganisms. We carry them with us all the time. The only way to be sterile is to really kill the organisms, which in the process also kills us. So there's truly no way, we have to find a middle ground between, what might get us sick and what is what we need to do to stay safe and healthy. So I also want to point out, if you look in the picture in the middle, that's an kind of a salmon color. So that tells us that it's part of one of the nodes in the station. Each part of the station has a color, and so the astronauts can know where they are just by looking at the color. After a while, it makes it easier for them. And it was an interesting process to work during the design of the space station and build up of the station, how these color codes came to be. Because truly in NASA, there's jobs for everybody. If you think about it, we have psychologists that have to decide, what are the right colors so you don't get all, there's colors that yellow, for example, you don't want to paint because it makes you hungry. So there's some psychological things that go with colors that have to be considered. There's also people that design all those bags that you see, the clothes that is used. So there's a lot of areas that we can talk about if you like. But I just want to bring your attention to this very old picture. Oops, it just went too fast. And you can see that station can get fairly crowded. And in this case, here in particular, I think we are in the Russian side. That's you can see the table that has the food in there. So nutrition also is important as for microbiology and for the crew and for long duration missions, because it's a time for everybody to come together. So psychologically, it's a good thing for them to eat together, so they can talk, so they can disconnect from work. Since they cannot go outside, this is a way of doing it. If you can look on the wall, you're going to see a lot of food in there. You can see tortillas. You can see what looks like cans of food. Also, this is an international endeavor, so you're going to see people from all over the world coming. So the food will also be, it will also be reflective of the cultures that the people that are in the station are from. So something else to consider. You can see, things on the walls that are related to the people that are there. And so it's an interesting mix of people. And so I am sorry about that chart is out of place. So we'll go back to that one in a minute. So again, you can see here is the salmon color that I showed you before, and you can see all the storage of stuff. And in these areas, there's a possibility of microorganisms or airflow that doesn't go right, giving us opportunities for growing microorganisms in places that we don't want them to be. So recycling water helps us have less water bags, and that's what this was in the early stages of the space station. Now we don't have as many bags of water stored, because since we are a lot better at recycling and it is so efficient, we don't have to keep such a large amount of water for the crew. A crew member can use about 2 gallons of water a day, by the way. And if you compare to that, how much water you need as a human, how much water we use as a human in the US daily is about 35 gallons of water. But it's because, you know, when you open your the shower, there's a lot of water that is wasted there. Same thing when you flush your toilet or you do your dishes. Well, none of those things happen in the station. Therefore, you know, they can use a lot less water. Plus, it's heavy, and you know, so it's expensive to bring it up. So it's a lot better to recycle it. Anyway, so for prevention, one of the things we still do in the station is we prevent the contamination by using HEPA filters, which you might have heard of a lot now since the COVID-19. There's a lot of talk about HEPA filters, but we have been using those for years and years. Inline water filters, they are not necessarily barrier filters, but it could be chemical filters. Contamination resistant surfaces. So we don't want to have carpets or fabric on the walls like you saw on the module from the Russian side that had the fungus. If you see the walls of the areas from the US station, they are stainless steel or titanium. They're not carpet or any kind of fabric. We use biocides like we use on the ground, but we don't use chloride. We use iodine. We also pasteurize water as needed. So the water is heated to temperatures that can take care of the organisms that are most dangerous to us. We minimize the condensation. So the temperature and the humidity on the station is very carefully controlled in the US side. And then we don't throw trash. We contain the trash and human waste. We try very hard. We are like the best recyclers in the world because we have to do it, otherwise we die. But also it makes, you know, if you can think the whole life of what you're sending up there from, you know, the time that you put your food inside very, very thin bags to the time that it goes back to be trashed, that doesn't take a lot of space, and even perhaps you can recycle, repurpose, or reuse. That's always a good thing. So we do that as much as we can in station, and most definitely that would be not a choice but a must in long duration missions. So we also preserve or prevent microorganisms by making sure that what we send up there is disinfected and cleaned very well. We monitor all the time the station for things for surfaces, air, and water. And the slides that you see on the bottom is the way that sometimes we can look for those right now. But for the most part, the station is extremely clean. There's many reasons why, and happy to talk to you if you're interested in that. So what you're seeing on the bottom are not examples of what it's in station. These are experiments that we have ran. We want to control the microorganisms, of course, because of infectious diseases, biodegradation, which is a big deal, by the way. Microorganisms can destroy surfaces. That can create system failures. It can spoil our food, and then also release chemicals in the air. So we don't want to have that happening. So right now, the International Space Station under the National Research Council is a microbial observatory program. So if you're interested in microbiology, this is a place that it's an amazing place to look at if you're interested. So let me know, and I'll be happy to either connect you or tell you a little bit more about it. But I haven't been doing microbiology. Well, that is a lie, because I was doing microbiology for NASA last week, but not full time anymore. So lately I have been working. Oh my goodness, I still have one. They are all out of place. This is a way I do, doing microbial monitoring station is an issue because the lack of gravity or microgravity. So everything takes longer and takes a lot of time to think of before you send it. So this is a way to monitor the water And so you can see what kind of strange looking things we have to do. The bags have to be designed to maintain the water without a lot of air. And you will see a filter in there, and then you will see another filter that will have the media and then a syringe. So there's a lot of things that we have to design. Again, happy to talk to you about it if you're interested. But now I want to talk to you about what I do now, which is we are running the multi-million-dollar competitions for the agency, looking at truly daring to ask the public, what if? What if we had better ways of storing our power, distributing our power, or even, managing our power so we can use more sustainable power sources like, air or wind and such. So we'll give you a little bit more information about that. But before we start, I just want to show you this picture because I think it is such a beautiful picture. And it shows the fact that we are going to be exploring the moon on our way to Mars. So even though it looks like we are spending a lot of money only to do space things, everything that we do, as you can see in this picture, have immense, at least the parts that I get to do, that's what excites me, have amazing benefits for our stay on the moon when we are there, our future on Mars, but in the middle of all that is Earth. So anything that we do, at least in the programs that I have worked, have a lot of benefits for all three of those places. So Centennial Challenge, which is what I do right now, it's about stimulating the research and technologies solutions for NASA missions and inspire new national aerospace capabilities through public prize competitions. We have run a total of 20, actually. We just opened a new one, challenges. Have had many teams that have participated, 307 right now. Excuse me, participants from 42 states, 24 countries, and we have awarded more than $10.3 million. And I'm going to touch on some of these very quickly. We currently have 5 competitions open. So the first one that I fell in love with when I started this program was the 3D printed hub, which is completed. And this competition was about building houses for using materials from the surface of Mars. And the picture that you saw where I show you the window that you can see Mars outside came from that competition. So I will recommend that you go to our website and NASA Centennial Challenges and see the beautiful pictures that were provided and the designs that are provided. But the benefits of a challenge like that is the companies that actually won these competitions are currently making 3D printed houses for homeless people in Austin, and they're also doing other things for Earth. A lot of technology happened because of these vertical construction of 3D printed habitats for Earth also got pushed, and we're super excited about that. Other than that, we have competitions in CubeSats, which are small satellites that can advance propulsion and communications in deep space. A vascular tissue challenge, which is about having viable tissue that has all the vascular systems necessary to be functional for a major organ in your body, like your spleen, your pancreas, your kidney, your lungs. The CO2 conversion challenge, which is about taking CO2 and convert it into glucose. Glucose is the most wonderful nutrient for bioreactors. We can feed bioreactors with biologically altered microorganisms that can make for us food, medicines, vitamins, bioplastics, pretty much anything that we want. So those are farms on demand. And actually, one of the companies that is competing in that competition just made a bunch of disinfectant during using CO2 during the pandemic in New York. So they're using it. Also, they made ethanol products and they disperse it for free using CO2 that they gather from the atmosphere. So it's a cool company, air company. So you just might want to go and look at them. And then space robotics, which is about autonomous systems for space on the moon, hopefully helpers for our humans on the moon and Mars. And then I'm going to talk about the last three in a second. So I'm just going to move and let you know that this is the roadmap for NASA. So we are going to go. We are definitely going to go. We're going to go to many places, but we're going to go and we're going to land on the moon. And on our way to the moon, we're going to learn a lot of things. And then we're going to live on the moon for a little while as we learn how we're going to get to explore places like Mars in the future. And so, hold on just a minute. So NASA has just opened what we call the Lunar Surface Innovation Initiative, which is includes things like in situ resource utilization. So this area is about collecting the material, the dirt from the surface of the moon, for example, which we call regolith, and using it to build things, or we can make, we think we can make oxygen from it. There's a lot of things we can do using the materials that are there. So the beauty of being able to use what it's in the places that we go is that we don't have to take it with us. We are also looking at having sustainable power, so we can actually do the things we have to do on the surface of the moon. Once we are there, there's areas on the moon that do not have any light at all, any time of the year. So, and those happens to be the places where we think there's water. So therefore, if we want to quote unquote mine the water on the moon, we're going to have machines that can store large amount of power to maintain, to be able to run those machines. We have extreme areas that have not good access, so it's extreme access, hard places to go to. And of course, as good explorers, if we're on the surface of the moon, we want to find ways to get to it. We also want to have a way to excavate and construct or build things that are affordable, autonomous, like the 3D printing of habitats that we talked about. We want to find ways to mitigate dust on the surface of the moon, because that dust is almost like flour, very, very fine, but it's also very jagged. And if it gets in your lungs, it can actually kill humans. Of course, you can think of, okay, while we're outside, we have our spacesuits, so we shouldn't have an issue with it. But the problem is that when we go back inside the habitats, if we go inside with our suits, which one way or the other is going to happen at some point, that dust gets attached to the suit. So we have to find a way to mitigate those problems. And it is not a very easy to fix problem. It's a pretty big problem. And then we talked about extreme environments. So it's going to get very hot and very cold at the same time. And for some reason, metals do not like that. They get brittle, they break. So, and pretty much all our machines are made of metal. So that's our issues. So with those thoughts, we have opened a brand new competition called What's on the Moon. And Chris, this is your cue to show them the video, please. Is Chris gonna be able to show the video?
Should be able to.
On Earth, we can light the darkness, power our lives, supply energy for the world's needs. On the moon, we cannot, or at least not yet. With 350 hours of total darkness and day after day of sub-zero temperatures, traditional Earth-based power storage and distribution technologies aren't going to be enough. Future lunar explorers will need power to use the tools and technologies necessary for uninterrupted exploration and survival on a new world. That's why NASA is searching for solutions beyond our ongoing research. From garage inventors to small businesses, industry, and university students, NASA's What's on the Moon Centennial Challenge is crowdsourcing ideas to solve the difficult tasks of power distribution, storage, and management on the lunar surface, and enhance these technologies here on Earth. As NASA builds a sustainable human presence on the Moon, continuous energy will be a critical piece of this puzzle, so that one day we can light the darkness on the Moon.
So that is our brand new challenge. Invite you to go and look at it and see if you are you can participate. If you can bring me back to my charts, please.
Yeah. So,
Monsi, I just need you to share your screen once more.
Okay. So I think I'm almost out of time. So the next one is a NASA's Break the Ice Challenge. It's about excavating the areas that the frozen areas on the south pole of the moon. And then the last one, but one of my favorite, is the Deep Space Food Challenge, which is about farming and food for the astronauts in deep space. And this is kind of a pantry on demand, a live pantry. And it's not only about plants. When we talk about farms, you can think of fish, you can think of insects, you can think of fungi, you can think of, all kinds of microorganisms, algae, all kinds of farming. So I don't think cows will be good for this, or chickens, but hey, if somebody can figure out how to put it in a small box, we can maybe do that too. So, so with that, that's all I have. And I think that's half an hour there. So happy to answer any questions you have.
Thank you so much, Monsi. This was such a wonderful presentation. We have some questions for you. And folks who are just turning in or maybe tuned in a little bit late, we are here with Monsi Roman, who's in charge of the NASA Centennial Challenges Program and also was vital to help creating some of the life-sustaining technology that we have on the International Space Station. So please, any burning questions for Monsi, send them along to us through using the chat window. And as I said in the beginning, one of the reasons that Pisces puts on these kinds of presentations is to help those who are early on in their career interested in working in the space exploration field. So if you are one of those, if that applies to you, we want to give you priority to answer your questions. So feel free to shoot us questions, including the hashtag WiSE, just when you send it off to the chat window. And with that, Monsi, I have some questions that we'll send along your way. We've had quite a few questions relating to the water recycling system that you mentioned on the International Space Station. So do we use those techniques on Earth in places where water is scarce?
So that's part of the things that make these developments for space super cool. We need to figure out how to do it for Earth applications. There's some issues about the systems that we use in space station, because as you saw, the amount of people we have in the station, it can be anywhere from 3 to 12. And of course, on the ground, we have lots and lots of people. In station, we can control, for example, all the chemicals that we put in the water. And on Earth, we don't have that luxury. In space, we don't have pesticides and things like that. That makes our systems, it can overwhelm our system. So, but that's why we need people like you, people that can have ideas on how to take those systems as a start. Those are a start to show what can be done. And people like you that, can think outside of the box and see how those systems, learn about them and see how we can make them bigger. Pieces of it have been used on the ground, but I think we can do so much better. Truthfully, we can do so much better. So yeah, that would be amazing to have systems like that on probably in a house. Somebody can patent something that can be used in one house, not or a small community. But that's a wonderful question and something that I invite you to be curious about. And I'll be happy to tell you more about it, the technologies, and see how we can do things at home.
Absolutely. I think that's in general just a really exciting aspect of the field you're in, is the ways that, potentially we can solve these very, very challenging and vexing problems in space and then bring back the technology to Earth to improve our lives here. So I have a couple questions also related to this idea of reusing our resources we have in space. Of course, water is very limited. You showed us that photo with those water bags. And so we have someone who asked a question that other than human consumption, what else is water used for? Is it used for the technology on the ISS? Is it used for experiments? Or is water pretty much there for humans because humans need water?
Well, the majority of it is for the humans, right? Because we, like I said, 2 gallons per person per day. And so if we have 6 people over there, you can do the math, and that's a good amount of water needed. But we also have experiments in space, in the space station. We run a lot of experiments, so water is used for those also. But truly it's mainly for humans and experiments. That's about it.
And
experiments sometimes include animals, by the way. I think I just saw somewhere something about they're flying some mice in the next few days. I'm not sure if that's or they already went up, or they're already up there, but you might want to. So our animals up there will also need water. So
true, important members of the space crew team as well. They should get water too, for sure. Okay, so you mentioned a little bit delicate issue talking about waste on the International Space Station. You made us all feel a little more uncomfortable when we saw that image that our astronaut friends in a year drink, 700 liters of recycled water. And then you mentioned, hey, we drink water all the time on Earth, that we don't know what other sources have contaminated it. Luckily, we have very good water quality inspection sites that help us feel more comfortable. But I have some questions about trash in space. Excess human waste, do we store it? Do we put it out back into space? Our resupply missions to the ISS, do they take back trash of all sorts, or do we incinerate it? What happens to trash?
So I see this is another way that we as members of Earth can learn from a lot and see how we can take a lot of our lessons learned and bring them down literally to Earth and see how we can make our life on Earth better. In space station right now, so there's a lot of thoughts coming here to my mind in a second, but the other thing I did mention that there's so many ways that you can be part of the NASA family, not only being a scientist or an engineer, a psychologist or things like that, but we also need fashion designers, right? Because right now, the clothes that the astronauts take with them in space station, they use it as long as they can. So it becomes fairly stinky. And when they finish with it, they have an option to perhaps wash it by hand, which is not the best way because they don't have a washing machine there at all. But for the most part, it's actually trashed. So the trash includes, in station right now, includes their clothes that they have used, all the bags from food, things from their experiments. All that is put in bags that are returned back to Earth on the Proton, which is a rocket that burns. There's no people there. It's just a rocket that comes back to Earth and burns on its way to Earth, because of the heat of the reentry. And so that's how we dispose of that. So we don't trash space at all. We don't throw things out in space. That's a big no-no. But when we go to our deep space missions, anything food related, even the packaging, our clothes, all that. I mean, if you are going on a 3-year mission to Mars, for example, and you're throwing away your clothes as you use it, at some point you're going to have 0 clothes because you can only take so much with you. And same thing for, so we need to think of ways to have a very net zero waste, zero waste mission. And for that, you have to design it from the time you design to the time, you use, and again, completely from life to death of that material. And again, rebirth of that material instead of from birth to use and then death and going into in our trash cans here on Earth. So just thinking, encouraging you to think what things we could do on deep space missions to maintain these no trash, policy is going to help us create things that are going to be so much better for us on Earth too, as we can recycle more, use things that are better for the environment, help our environment in the process, and help ourselves in the process. So,
absolutely. It's also just funny thinking about how you're saying, like, all of these things that we have in the ISS need to be thought about how we can optimally design them for being in space. And it was funny, that photo you showed of the astronauts from a while back sharing a meal together. And it looks like they're all just wearing normal clothes. And it was something that was striking to me as surprising. Like, oh, right, of course when you're in the ISS, you're going to wear normal clothes. It's not like you're always in an astronaut suit. So all of these little details need to be considered very particularly.
Well, I mean, things like brushing your teeth, so if you are going to a long duration mission on the surface of Mars, think about, your toothpaste is going to run out. There's no supermarket there that you can go and get it. So you have to think of all those things up, very carefully. Clothes, pens and pencils and paper, and it's little things. Sometimes it's not the big things, but the little things that are gonna get you. So
absolutely. All right, I'm going to ask you another question about the ISS, and then maybe we'll move in talking a little bit about your own journey and how you got to where you are and advice you have with respect to career tips and working in similar fields. But we have a couple questions, and they're related to this idea of breathing with an International Space Station. That you constantly have to have fresh oxygen, but we also have to think about what to do with CO2. So we have one question asking about, what do we do? How do we make sure that we don't have too much CO2? And specifically, we have a question from Rodrigo Romo at Pisces, who was fortunate enough to be on the Biosphere 2 experiment. And so he mentioned that there was this issue with CO2 being absorbed into the concrete structure, resulting in a net loss of oxygen within the biosphere. And so it got to the place where the conditions weren't very safe for crew members, and they'd keep adding oxygen into the system. So what do you do in the International Space Station? Do they experience a similar oxygen depletion situation? And how low do they get it? And are they, how do they measure these CO2 and oxygen levels? And what do they do to have to make sure that their crew members are safe?
So one of my charts have a recycling system that shows Earth on the middle, and then have all kinds of, if I had the chance to talk to you at a longer time, I would tell you all these things with more details. But basically, so we don't have trees in the station, right, that can take the CO2, but we have machines. We have replaced the function of the trees, or even the microorganisms in the ocean, by the way, which are the biggest absorbent of CO2 in the world, even bigger than trees. And that we don't have any of those, at least not right now, in station. So we have boxes that will take the CO2. And so keeping this mantra of recycling, right? So the CO2 will go to the 4-bed molecular sieve. That's the name of the box that it goes to. So it has 4 beds. That's why it's called 4-bed molecular sieve. And so the molecular sieve is like pellets, and there 2 of those beds have those pellets that absorb the CO2. And the chambers on top, the other 2 chambers are full of silica, which absorb moisture. So the air will go through one of the canisters. There's 4 canisters divided in 2. So there's silica pellets, silica pellets, and I think you can see me. I thought I was talking to nobody here, but yeah, I'm in the pit. So the air goes into the silica. Silica takes out the humidity, because once it goes to the pellets rather have humidity or water than CO2. So you want to remove it all before it goes there, so it takes the CO2. And so they are working, when one is working, absorbing, the other one is desorbing the CO2 out of it. And so you desorb it by heating it. So you apply heat, the CO2 comes out of the pellets, and the CO2 goes to another machine that takes that CO2. And what it does is takes that oxygen and mix it with hydrogen that comes from another system in the water system, and makes water and it can also provide oxygen to the crew. So in the process of, in the beginning, we will vent the CO2 to the atmosphere of space, just release it. But we figure out a way to take it and reuse it and maintain. Again, in deep space missions, you cannot afford to be releasing that out. And about absorbing the CO2, and in this case, I explained to you that the surface of the US side of the station are made with materials that cannot absorb the CO2, for example. So it's basically a metal. You're in a can, literally in a can. And that is so it can be cleaned easily. So there's the humidity, if any, can be wiped easily. And also, so things like that, absorption of chemicals like that does not happen.
That is so cool. I assumed you were going to say, oh, maybe we vent it out, or this is a problem we have to really think about. That is just incredible that you found ways to repurpose that. Wow. It is just so cool to think about these technologies that we have being used in the ISS every day. So we do have a few more ISS questions coming to us, but I want to make sure that we have an opportunity to talk about you and your own career journey. So we have a question about your interests, when you were younger, let me see, make sure I get this phrasing right. What are some of your childhood memories that maybe influenced your career choice? When did you decide what you wanted to do? Your early memories that helped influence you working in microbiology and maybe later on to NASA.
So I always loved biology. From all the classes I took, it was the class that actually truly spoke to me. And I was always in the science fairs, not because I had to, but because I wanted to. We had aquariums where I would go. Of course, living in an island always helps. So back then we could go and fish. We had all kinds of things in our aquarium. I mean, we had seahorses and octopus and, all kinds of beautiful fish. And that alone is a science fair on its own, because maintaining fish, even though we live in an island, I could go every week to pick up brand new water, to refresh the aquarium. You had to keep up the pH. You have to, some fish didn't like other fish, and you will find that very fast. You will find that your octopus didn't like to stay in the aquarium, and they're super smart, and they get out of it, and you have to keep putting them back in the aquarium. So there was a lot of things that you learn by growing up in an island like that. But biology was always my passion, and I loved the science, and I had amazing teachers that at the time, that was a long time ago, girls were not, supposed to like science as much. Truly, we were not as encouraged to go to those paths. But I was very lucky to have teachers that put up with my craziness and my thinking always, going out. And when I started, I was very lucky to go into a magnet school in science and math. And I hate math with passion. I do have to say that. But in order to do science, you need math. So I figured out, it was the evil that I had to do in order to do what I really wanted to do, which was the science side. And now, by the way, math is very useful. I'm not saying don't hate math. I'm just saying you don't have to love math or be very good at it to be able to have a career in science, as long as you understand that you have to, it's an area that you have to work harder, because the biology and the science, because you love, is the one that is going to be easier for you. But you cannot do it if you don't, you have to find the balance in those two. When I went to college, I was very lucky to have a class in microbiology from a professor that was in sabbatical from Berkeley, and he was teaching microbiology, and I took the class with him, and fell in love with the field. He took me as part of his laboratory, and I got to start doing research from the second year in college in microbiology, looking for microorganisms and organisms in the mangrove. So I got to go to the beach pretty much every day, pick up samples, bring them to the lab, and do all kinds of things. So it was pretty cool. So that's how I fell in love with the I did not know what I loved biology. I didn't know where I was going to go. I wasn't sure I wanted to go to med school because I didn't have the money to do that. So I never thought that's the way. I thought maybe dentistry, but I hated the dentist. And so it opened doors that were not open at all before. And when I was in school, there was no space microbiology. And when I was hired at NASA, there was no space microbiology. So I had the opportunity to grow with the field, as I started. So which was an amazing opportunity.
And this actually leads us directly into the next question, which is, from a participant who wants to know, what advice would you give us for those who are interested in pursuing graduate research in microbiology applications in space? How do we find folks working as microbiology graduate advisors who might have shared interest in human spaceflight?
So find the research. One of the things I do a lot when I want to do something, whatever it is, even now to this day, I look and especially now you can Google anything. So Google who is publishing in the area that you like. For example, Dr. Hazen was the person I work with, and you can see a lot of information. If you Google his name, you're going to find a lot of papers of him in the areas of microbial ecology, and Rita Colwell. And so there was a lot of people that I immediately got, that my professor actually put us in contact with, but because we didn't have Google back then, but now you do. So just Google the area that you like, find who is publishing in the areas that you like. And you might find some areas that you have not even heard about before, by the way. Microbiology is everywhere, anywhere around you, everywhere. So you can do clinical microbiology, you can do food microbiology, you can do environmental microbiology, which is that's what I do. You can do pretty much any microbiology. There's so many, you can go into molecular microbiology, which will take you to do, all the kind of awesome things that are happening right now with COVID-19. That is microbiology, people. This is just, the field is just there and so important for everybody. Just Google and send them a note. Tell them, hey, I'm interested in such and such and such. And maybe 9 out of 10 people are going to not respond to you or not, but that person that does respond to you, that is going to mean the difference for you forever. And so just find a mentor. There's always somebody there that can help you. And when I finished microbiology with Dr. Hazen, I thought because I had told him I wanted to work for him, and the class finished, I got an A, and I thought, surely he's going to tell me come and work in my lab. And he didn't. And I was heartbroken. And I was walking by the lab one day and he saw me and he looked at me and he said, I thought you said you were coming to talk to me. How come you have not come? And so I'm like, oh my gosh, I'll be there like right now, So I don't, sometimes you might think that you're not worthy or that they might, don't think that at all. Always think, go to yourself, just trust that you are good enough. You are. I come from nothing. I'm not kidding. And I just wanted to learn. I just had that passion, and they can see that. And you demonstrate what you have in the class, and maybe in the beginning people might not notice, but slowly you're gonna make them notice you. So just never say no to opportunities that are in front of you either. Anybody, just give it a try and see what happens.
Email someone, they can say no, but maybe they'll lead you to a really wonderful opportunity. You just don't know. And this also, maybe you answer this a little bit, but I do want to ask you directly. What advice would you give to your younger self, early career self, about what to do or about what to do or about what not to worry about when embarking on one's career?
Well, it's kind of, I'm not sure how to answer that 100% because I think it's always good to have this little thing in your head telling you perhaps, you need to do more because it makes you do better sometimes. So not have that's thought that you are the best or that you're the, it's always good to be open to other people's advice and other people's ideas, not to think that, but there's a balance between, not being completely how you say it, in a way, not open to opportunities and ideas from other people, and also have no self-doubt, just know that you are good enough, without being stuck up, or, you have to always be humble and polite and open and friendly, and, but keep, and it took me a long time to figure out that I am good enough. I mean, I truly am good enough. But in the beginning, it just was not. It just took me a while to say, okay, here I am, and this is me, and I can do this, and what I don't know, I can learn, and I'm gonna make mistakes, and I'm gonna own my mistakes, and I'm gonna do better, and it's okay. Everybody's the same, so.
I think that's so important to remember. I think it's also so important to hear from you, Monsi, who's done so many incredible things with your career that even you sometimes have imposter syndrome feelings, or feel like you're not good enough, or know that you can make mistakes, right? I think sometimes people think that scientists have to always be perfect, that we have to leave a little parts of ourselves or our personality when we're going into our quote unquote science or quote unquote engineering roles. And so I think it's really wonderful to hear from you. In the same way that it was really important to hear about the things like your family and your dog and the things that make you who you are. You're not just an incredible, awesome microbiologist working at NASA. You're a complete person. And I think those are things that are important when we're doing all of science outreach.
And something interesting about scientists in particular that I have found out working with engineers, I was the only scientist working with the engineers designing these systems. We love to argue. I mean, we love science. If you love to argue, you are a scientist. Just remember that. That's how we communicate with each other. That's how we get our best ideas through to others. So this is my idea. Tell me why is it wrong? Because so this is how you balance that. So learn to do that in a humble way, in a way that is growing everybody, not making anybody feel bad. But own it. I mean, because that's how you learn, that's your style. But also understand that there's sometimes with engineers, especially, I have learned, it's very intimidating for them if I start arguing with them. So find ways to communicate with them in a way that they can understand you, not as a troublemaker, but as you are just inquisitive, you are want to learn, you're curious. Just learn who you're communicating to, so you can communicate effectively with, and so you can collaborate instead of arguing all the time in ways that are not positive.
Totally. So this next one has to do with this is, unfortunately we're getting to the end of our time here today. But we have folks who want to be able to stay up to date with some of the products you're working on. Are there places that you could point to on the NASA website, or do you have social media sites that you maintain so that we can continue learning about your work?
So NASA Centennial Challenges has an amazing website, and you can go in there and see the competitions and follow the competitions if you like. My group, in my group, I have somebody that handles all the social media, and so it's at NASA Prize in there, so you can go and see at NASA Prize, and definitely Amanda can let me know if there's some questions or something in there. And you can find me Monsi Roman at Monsi Roman, so not very in Instagram.
For all of our folks tuning in, it's at Monsi Roman on social media.
In Instagram, and in I think it's Space Gal Monsi at in Twitter.
And then it's at NASA Prize. Awesome.
Yes.
So those are ways that folks can continue to stay in touch with Monsi, her team, and continue learning about their exciting work. With that, unfortunately, I think we're coming to an end of our session. But a huge, huge mahalo, a very, very big thank you to Monsi. Monsi, thank you for taking the time to talk with us all today.
Anytime. Thank you so very much, you guys, for the opportunity. And if you need to contact me, either Mimi or Chris know how to contact me. So happy to, if there's something I can help you with, happy to do it. And I really want to welcome all the witches that might come out of this presentation. Take it and own it happily, because we are the ones in the lab doing the test tubes and such. We're not the princesses doing the chores Although we can do that too. I mean, we can do anything we want, but
Awesome. Thank you so much, Monsi. And of course, thank you, Pisces, for hosting this wonderful talk series. Thank you, Microsoft and Hawaii Science and Technology Museum, for being our really wonderful sponsors. And the fun doesn't have to stop here. Please join us tomorrow at 10 a.m. We'll be joined by Amanda Hendricks of the Planetary Institute, and she's going to talk all about the awesome research that's happening in the mission to Saturn, with the first probe that is ever going to enter its orbit or entered its orbit with the Cassini mission. It's really going to be a wonderful time, and so you'll have opportunities to ask all of your burning questions about probes that we send out to these gas giants, any questions you have about Saturn, or any questions you want to know about someone who's an astronaut candidate finalist like Amanda Hendricks. So please join us tomorrow, and thank you for everyone who tuned in today. And if you have a couple moments, we would really appreciate any and all feedback we can get. We put on programs like this because we want to support your interests and help support your career development, right? So please give us any and all feedback. There's a QR code on your screen that you can use to take you to the survey, or there's a direct a URL link that you can use. So if you have the time, please consider taking the survey so we can get a little feedback and improve this programming. Again, my name is Mimi Fuchs, and hopefully I'll see you guys tomorrow as we're joined by Amanda Hendricks. Mahalo, guys.
Bye.